AI agents are one of the most talked about ideas in technology right now, but most explanations skip straight to the hype without ever showing you the actual mechanics. By the end of this video, you will know exactly how AI agents work, from the moment they receive a goal to the moment they decide they are finished. Let us start with the obvious question. What actually is an AI agent? The shortest honest answer is this. An AI agent is a software system that takes a goal, figures out a plan to reach that goal, uses tools to act on that plan, and then checks whether it worked before deciding what to do next. That might sound simple, but it is a significant leap from a standard chatbot. When you ask a regular language model a question, it reads your message and generates a response. One input, one output, done. An agent is different because it runs a loop. It can take many steps, across many rounds, before it decides the job is complete. That loop has 3 stages that repeat over and over. First, the agent perceives its current situation. That means reading the goal, checking any memory it has stored, and looking at the results of any actions it already took. Second, it plans the next action. Third, it executes that action. Then the whole loop starts again with the new information the action produced. The planning step is where the reasoning lives, and this is the part most people find surprising. The agent is not following a hard-coded decision tree. It is using a large language model to think through the problem in natural language, almost like writing out its own internal notes before deciding what to do. Researchers call this chain of thought reasoning. One of the most widely used patterns right now is called a react loop. React stands for reasoning and acting. The agent writes out a thought, chooses an action based on that thought, observes the result of the action, then writes a new thought. That thought-action observation cycle keeps repeating until the agent decides it has enough to produce a final answer. Now here is the key insight about actions. An AI agent on its own only knows what is inside its training data and the context window it can read right now. It cannot browse the internet, run code, or update a database unless it is connected to tools that do those things. Tools are what give an agent real reach into the world. A tool is essentially a function the agent can call. Common tools include web search, which lets the agent pull current information, code execution, which lets it run Python or other scripts to do math, process data, or test logic. File readers, calendar APIs, email systems, and database queries are also standard. The agent decides which tool to call, passes in the right inputs, and reads the output that comes back. This is also why you hear so much about function calling in language models. When a model supports function calling, it can output a structured request that says, call this specific tool with these specific parameters, instead of just writing text. The system running the agent reads that structured request, executes the tool, and feeds the result back into the next loop iteration. Memory is one of the most underrated pieces of the whole system. There are 2 main types. The first is in-context memory, which is everything the agent can see right now inside its active context window. This includes the original goal, the conversation history, tool outputs, and the agent's own reasoning notes. The problem is context windows have limits, so long tasks can run out of space. The second type is external memory, sometimes called long-term memory. This is a database the agent can read from and write to across sessions. When an agent finishes a task, it can store a summary of what it learned. The next time it runs, it can retrieve that summary and build on it instead of starting from zero. This is what lets agents feel like they have persistence over time. There is also a concept called semantic memory retrieval, where instead of reading a full database, the agent runs a similarity search to find the most relevant stored information for the current task. This is powered by vector databases, and it is how agents handle large knowledge stores without blowing up the context window. When one agent is not enough to handle a complex task, you get multi-agent systems. The idea is straightforward. An orchestrator agent receives the top-level goal and breaks it into subtasks. It then delegates each subtask to a specialist agent that is configured or fine-tuned for that specific type of work. The specialists report back, and the orchestrator assembles the results. This architecture is powerful because it mirrors how human teams work. One person coordinates, others execute specific parts. In practice, you might have an orchestrator agent that delegates web research to one agent, data analysis to another, and final report writing to a third. Each specialist can run its own inner loop, call its own tools, and return a structured output to the orchestrator. Frameworks like LangGraph, AutoGen, and Crew AI have made it easier to build these multi-agent pipelines. They handle the message passing between agents, the state management, and the routing logic so developers do not have to build all of that from scratch. The underlying mechanics are still the same perceive plan act loop, just distributed across multiple agents running in coordination. Let us be honest about where these systems break down, because the failure modes matter as much as the capabilities. The first major failure mode is tool errors that compound. If an agent calls a tool and gets back bad data, and it does not catch that error, every subsequent reasoning step is built on a broken foundation. The agent can confidently work toward the wrong answer. The second failure mode is context window exhaustion. On a very long task, the agent's active memory fills up. Older reasoning steps and tool outputs get cut off. The agent loses track of constraints it was given early on and can start repeating work it already did or contradicting its own earlier conclusions. The third failure mode is poor task decomposition. If the planning step breaks a goal into subtasks that do not cleanly cover the full problem, the agent can finish all the subtasks and still miss the actual goal. This is an area of active research, and current agents require careful prompt engineering and guardrails to stay on track across complex multi-step tasks. Despite these limitations, AI agents in 2025 are already handling real work. Software engineering agents are writing and testing code across entire repositories. Research agents are scanning hundreds of documents and producing structured summaries. Customer operations agents are resolving support tickets end-to-end without human intervention. The gap between demo and production is closing fast. So, where does this leave you? If you are a developer, understanding the perceive, plan, act loop and the role of tools and memory is the foundation you need before picking any framework. If you are evaluating AI tools for your work, knowing these mechanics helps you ask the right questions about reliability, error handling, and data access. The label AI agent can mean many things, and now you know what to look for under the hood. If this breakdown gave you a clearer picture of how AI agents actually work, hit the like button so more people find this video. Subscribe if you want the next one, which covers how to build your first AI agent from scratch using tools that are free to start. That video walks through every step, including the parts most tutorials skip. See you there.